going to discuss our 700 pint model and the difference between our 700 pint and the rest of our product lineup. The main difference being that it has an inverter compressor. So we want to have a little chat about our 700 pint model. It's our first one in our lineup to have an inverter compressor, and this really gives people a lot of variability when they're trying to, control a room and flatline it by not having to have, humidity spikes. So the unit will ramp up, ramp down on, the demand of humidity in the room rather than having an on-off like traditional dehumidifiers have. Absolutely. So it's something we're really excited about. Mark, why don't you kind of speak to that a little?
Yeah, I mean, we're all aware of, a dehumidifier, it turns on, it turns off, turns on, turns off, right? We've had inverter technology in the refrigeration industry since, I think, somewhere in the 80s is when it was implemented, where they started using these inverter compressors in Japan. And the technology's, really taken over in the air conditioning sector. You're just starting to see it in dehumidifiers, and obviously us trying to be part of the leading in the technology in this sector. But what there's other inverter products out there that they're a little bit different than ours, and one of the main features is that with our unit, you're going to have the ability to control it externally with a variable signal. So what that means is you can have a full other, let's say, Trollmaster system with a 0 to 10 volt signal, and 10 volts would be the units are running at 100%. 20 volts would be running at 20%. Oh. So with the 0 to 10 volt signal, right, you're setting the pace of where you want that unit to run at, right? Do you want it at 100%? Do you want it at 50%? So if you're looking at a graph, right, and as let's say you do a watering, let's just use an example. If you just did a watering, the plants start transpiring, the load just goes through the roof, right? All your units are running at 100% in your room. At some point, you're going to get to a position where your room is now under control, right? And in a typical environment where you might have staging of dehumidifiers, as your room gets to set point, you're going to shut off stages of dehumidifiers and try to manage that load, right? Yeah. With a 700 with a variable input is now you can just ramp that unit rate down, right? The whole goal is never to, you don't want to be in a position where you're actually overtaking, you don't want more dehumidification than the space needs. You want to match the load, right? Yeah. Whatever that load is in latent load, you want to match it specifically. So now you have the technology to do that, right? So it's going to be really interesting to see what growers can do with this product, because we've never had anything like it in the industry where you can take a room and completely flatline the humidity, right? What happens when we take a room and give the plant the perfect environment in the perfect situation? Right? We don't know, right? I mean,
well, that's when you get your maximum
we've
yields.
always tried to, we've been evolving to that, but here we are on the VPD and the dehumidification side where we can actually potentially do this. So.
And when you're talking about the ramping up, ramping down, that's going to be the inverter and the fan speed.
Correct. And a lot of people confuse that. They just think that ramping up, ramping down means the fan, right? The fan is only one component of it. It doesn't control the actual amount of dehumidification or the refrigeration effect that's occurring. That's the compressor. And normally, in most situations, that compressor is one speed. It can only go that single one speed. It's on or off. The fan will be the variable portion, where ours, the compressor and the fan are both variable. So they're going to sequence together to make sure that it optimizes the best efficiency possible.
Okay, and then counter to what a lot of people may think, it's actually less damaging on your equipment for it not to turn on and turn off. Like it's going to give you a longer lifespan than having those hard starts, those hard shutdowns.
You look at a car, right? I mean, it's like highway miles compared to just, city or on, off, right? It's the starting that's hard on the unit, right? Yeah. You also got to remember a compressor, every time it starts, it has a pressure differential between the high side, which might be 250, 300 PSI, and a low side that's maybe 50, 60 PSI. It has to overcome all that pressure just to start, right? So normally we're using starting components just to manipulate the electrical current load to make the torque change so that we can get enough torque to even start that compressor. I mean, that's hard on a mechanical piece of equipment, right? Mm-hmm. So you can imagine if you could just ramp that thing up, ramp that thing down, and maintain that speed, it can run forever, right? I mean, we've seen, Copeland, which is one of the largest compressor manufacturers in the world, they have units in their factory that they've been running for 70 years. And what it is, it's a big ball of ice just to prove that you can run as long as the unit's not taking liquid refrigerant and it's pumping vapor. Even if it's a ball of ice, it will just continually run. So the capabilities of compressor, because it is cooled from the refrigerant, it has a lot longer longevity than, let's say, just a standard air motor that could be operating, right? Because it's always going to be cooled. Those windings are never going to get hot. Provided everything else and all your fundamentals of refrigeration are working, it can run forever. So, but a big part of it is start stops. You don't want to prevent that. So
yeah. And then you mentioned compressors there. So you mentioned Copeland, which is a domestic brand. You know, for our products, we're using GMCC, which is Toshiba.
Yeah. So GMCC has been around forever, and they manufacture pretty much a lot of the inverter technology for a lot of the other manufacturers that are in Japan, in China, in Asia. And so their technology is far above, and they've been doing this for many years longer than we have, right? So, I mean, in North America, we are taking their technology and started implementing it 10 years ago, and now it's starting to really take off. But they've been doing it since, like I said, the 1980s, that they've been using this.
And then there's the two different types of compressors, the rotary and the scroll.
The most common in the HVAC industry, dehumidifiers and HVAC AC equipment that we see in our industry, it's mostly scrolls the most common, rotary being second.
Yeah.
You know, you still see reciprocating, which is an older technology that was used for many years. Reciprocating is a less efficient compressor. I mean, we want to stick to the most efficient, especially, you know, being in a position where we want to make the absolute most efficient unit possible.
Yeah.
You know, we're stuck with a certain brand of compressor, but the one thing with the rotary too is that it's very robust. There's very few mechanical moving parts, and that means less to go wrong, right?
Yeah.
And you know, we really want to push the envelope as far as reliability.
And then another safety feature we have on all of our compressors is the accumulator.
Yeah. Yeah, and that's another thing, you know, unless you open up our unit, you wouldn't know what the big ball of, you know, what nothing is, right? That's just basically right outside the compressor. It's very common in HVAC industry in low temperature applications where if a compressor actually took a ball of liquid or took a slug of refrigerant, it would smash to pieces, right?
Yeah.
They're vapor compressors, right? They're not designed to slug liquid. There's always potential, whether, you know, varied conditions, low temperature conditions, where it could actually take a slug of liquid. So to prevent that or mitigate that issue, we just use an accumulator. So that accumulator is an added protection. If we somehow were to have liquid refrigerant trying to enter the compressor, it would accumulate in the accumulator, and then therefore preventing that compressor to smash into pieces. So you might never see it, right? But it's added protection, right? And the last thing we want to see is, you know, be in a situation where your unit just came out of warranty, and you know you somehow put it in a really robust condition or a really challenging environment, and somehow that compressor took a slug of liquid and smashed to bits, right?
Yeah.
It's a very simple, inexpensive component to add to give a customer longevity that they're expecting.
Yeah, and I think it's just one more thing that we're doing at Cannadri is we're trying to figure out how do we make our equipment last as long as possible and have as little downtime. You know, being from the growing industry, this is something that we ran into ourselves, and that was the tempest for why we started this company. For more information on this, feel free to visit our website or follow us on social.